Hello, let's learn about radical and rational equations. First of all, radical equations. These are not equations that are going to overthrow the government with their crazy ideas. They are equations which contain some sort of root. Generally, you're looking at a square root. I really don't know why they're called radicals. So here's an example from one of our tests. What is the solution set to the equation above? I think you might already have an idea for how to solve this, so let's go ahead and pause the video and see if you can give this a solve. So here's what I would expect to see. First of all, we want to get rid of the square root. So how do we get rid of the square root? By squaring. Now, if you go ahead and square both sides, this doesn't work very well. Why doesn't this work so well? Well, if you were to, quote, distribute the square root here and here, and get 2x plus 6 plus 16 equals x plus 3 squared, this would be very sad, because you would have to go to jail, because the math police would come and arrest you. This is not one of the rules of exponents. So, to square both sides properly, instead of distributing like that, you would actually have to square this binomial. And that would not get rid of the square root. That would give you 2x plus 6 plus 8 root 2x plus 6 plus 16. If you're confused about why, you can go ahead and ask a question, but when you expand this, this is what you'll get, and you can actually do it to verify. So that does not get rid of the square root. So as many of you hopefully saw, the correct idea is to first subtract 4. Now that you have the square root isolated, you can square both sides. And now we don't have this annoying binomial on the left. 2x plus 6 equals x minus 1 squared. Let's go ahead and expand. You should be familiar with perfect squares by now. It should be easy to expand them. And then this is a quadratic equation. We know how to solve quadratics. We're going to set it equal to 0 by subtracting. And then we can factor. Just doing our normal quadratic technique. And we use the zero product property. And we get x equals 5 and x equals negative 1. And so we pick C. However, C is the wrong answer. If you're confused about why C is the wrong answer, take a moment to pause and discuss. See if anyone in the class can explain it. Okay, that's right. One of these solutions is not actually a solution. One of these solutions is an extraneous solution. Radical equations sometimes have extraneous solutions. That is the solution that we found here, but when we plug it back into the original equation, it might not actually work. So the best method is to check and make sure that these solutions are actually valid by substituting them back in. If you have not already done this, go ahead and pause and try to do this for yourself. So if I try x equals 5, I get root 16 plus 4 equals 5 plus 3. That is 4 plus 4 equals 8, which certainly seems true. X equals 5 seems to work. Let's try x equals negative 1. When I substitute that in, I get root 4 plus 4 equals negative 1 plus 3. That is 6 equals 2. Not correct. So x equals 5 is correct. X equals negative 1 is not correct. X equals 1 is what we call an extraneous solution. So what's happening here? How did we do all of this algebra and end up with a solution that was wrong. Surely one of our steps here contains an error. Can you figure out which step contains an error? Feel free to pause the video and discuss. So that was a bit of a trick question. None of these actually really contain an error, but if you look at what we did, first we subtracted 4 from both sides. That's a pretty safe thing to do. And then we squared both sides. We did more subtracting, factoring, and the zero product property. By far the most suspicious step is the step in which we square both sides. And that is indeed where the problem arises. If you plug x equals 1 into the original equation, as you saw, we got 6 equals 2, which is not true. Imagine the next step here. What if you plug in -1 here? If you plug in -1 to this step, you get the square root of 4 equals -2. That essentially comes down to 2 equals -2, which is not true. But notice if you square both sides, it becomes true. It becomes 4 equals 4. So squaring both sides is actually where the problem lies. By squaring both sides, you've introduced solutions. You've taken two numbers that are not equal, that is -2 and +2, and made them equal by squaring. Does that mean that squaring both sides is wrong? No. But you have to be aware that you could be introducing extraneous solutions. So there you go. If you square both sides, you may have extraneous solutions you need to check, and you often square both sides of a radical equation. So C is not the right answer. In fact, we want B. Now there is a totally different way to solve this problem. Can anyone see what it is? I sure hope you can, because I've talked about this enough times. That is, you can just plug in numbers. What numbers would you plug in? Well, the answer choices. The answers are all right there. In fact, there are only 3 numbers to check: 0, -1, and 5. Those cover all of the answer choices. So all you have to do is plug those into check and see which of them work. This is incredibly easy. And so I would expect everyone to get this problem right every time on the SAT. When you see one of these, you should be just like, oh yes, thank you, free points, and accept the gift. If you have, let's pause and see if you have any questions. All right, now it's your turn. I'd like you to solve this radical equation and then check for extraneous solutions. Go ahead and pause the video and do that now. Let's walk through the solution together. I square both sides. I get this, set everything equal to 0. Like so, do some factoring. X plus 2, x minus 1. And I get x equals -2 or +1. Let's check for extraneous solutions. Starting with x equals -2, and I get root 4 equals -2. 2 equals -2. Suspicious. It does not work. Let's try x equals 1, and I get square root of 2 minus 1, which is 1, equals 1. This is true. So x equals 1 is the only solution. It is possible to solve an equation and get no solutions. That is certainly possible. A good example of that would be if we were to solve an absolute value equation. Consider the absolute value equation, absolute value of 2x minus 1 plus 3 equals 1. We've talked about how to solve absolute value equations before. Go ahead and pause and give this one a try. So the technique we talked about before was to separate this into 2 equations. First of all, if 2x minus 1 is already positive, then the absolute value does nothing. And you get this, which we can solve. What is this? -1. Or if 2x minus 1 is negative, then the absolute value makes it positive by multiplying by -1. Again, this was a topic that we discussed at some length earlier in our course. I'm going to multiply both sides by -2. Okay. Are these solutions both valid? Well, let's check by plugging them in. First of all, I'll start with x equals -1/2, in which I get absolute value of -2 plus 3 equals 1. This is 5 equals 1, which is not usually true. No. Let's try x equals 3/2. When you plug it in, you get 3 minus 1, which is 2, plus 3 equals 1. Again, 5 equals 1, which is not true. So there are no solutions to this equation. The only solutions we got were extraneous. One of the ways you could have seen that is by subtracting 3 on both sides, and you would have ended up with absolute value of 2x minus 1 equals -2. Now, if you think about it, how is it possible for the absolute value of something to give you a negative answer? And that should be a clue that this has no solutions, and you could save yourself some time. So bravo if you recognize that right away. Go ahead and pause and see if we have any questions. Next, let's talk about rational equations. Rational equations are equations where you have some sort of rational expression, meaning some sort of fractions. We've dealt with rational expressions before. Now it's time to solve some rational equations. So go ahead and pause and try to solve this. Okay, here we go. So whenever I see a rational equation, I want to get my my variables out of the denominator here. I'm going to multiply by x minus 8. Okay. I'm also going to multiply both sides by 2, because just get rid of the fraction. That way I don't have to deal with it. So we have 22x plus 4. Let's distribute the -3. And we get x equals 4/5. Great, that's it. Nice, good job. But it gets a little bit more tricky. So next example is this. Now here you notice we have some sums going on. As we've previously discussed with rational expressions, you're going to actually want to do the addition, which means you need to make a common denominator. Remember, the way we talked about making a common denominator was to multiply top and bottom by 1. That is, for this x plus 20 and x, we need to adjust each one. So first of all, for this one, I'm going to multiply top and bottom by x. Multiplying by x over x is the same as multiplying by 1, and that is legal because multiplying by 1 doesn't change the value of the fraction. For 24 over x, we're going to multiply top and bottom by x plus 20. And then we're going to have a common denominator of x times x plus 20. On the right side, we'll do the same thing, multiplying 11 by x squared plus 20x on the top and the bottom. And that should be all we need to do. So at this point, I'd like you to try and finish off this problem. Go ahead and pause the video and give it a try. All right. When you distribute the things, you should end up with something like this. 11x squared plus 24x plus 480 over x squared plus 20x equals 11x squared plus 220x plus 88 over x squared plus 20x. And if we have two of the fractions that are equal and they have the same denominator, then of course their numerators must be equal. So we'll set the numerators equal, and then we'll try and solve for x. Now conveniently for us, there's 11x squared on both sides, so you can subtract it and combine like terms. And divide, and we get x equals 2. Wow, great. So when you see a rational equation, that is equation involving fractions, make common denominators and solve. If these 11x squared hadn't subtracted from both sides, then you would have ended up with a quadratic equation, so just go ahead and set it equal to 0 and solve, and you could have ended up with two solutions. Now is a good time to pause and ask questions. All right, here's one last example. Go ahead and give this one a try. Pause the video and see if you can solve it. Here's the setup for the common denominator. It should be pretty straightforward, and conveniently, the right side already shares a denominator with this new left side. So all we have to do now is do some distributing, some combining of like terms. Let's do that. Oakley dokley. Now let's do the same thing we were talking about before. That is, if these fractions are equal and they have the same denominator, we'll set the denominators equal to 0. I'm sorry, equal to each other. And do some factoring. This time we did end up with a quadratic. And solving for x, we get x equals 0 and x equals -2. However, there's a problem. This is not correct. Can anyone see what's wrong with this? Pause the video and discuss. That's right. We have an extraneous solution. X equals -2 is an extraneous solution. Why? Because it makes your denominator 0. Substituting it into the original expression causes us to divide by 0, actually on both sides, which is bad news bears. X equals -2 doesn't even work in this step. It was in fact this step where we introduced the -2 as the solution. This thing that I said before about if two fractions are equal then and they have the same denominator, then their numerators must be equal is true. However, it doesn't it's not complete in that just because the numerators are equal, that doesn't basically work this way. And this is exactly the reason why. So rational equations sometimes contain extraneous solutions as well. In particular, any solution which would cause you to divide by 0 is not good. So right away, looking at the problem, you should be able to tell that x equals -2 and x equals 5 are not valid solutions. So if you get either of those, you know that they're going to be wrong. And that's what I'd like you to think about when you see a rational equation. Immediately say to yourself, aha, those can't be solutions. Now it is possible to get two solutions that both work. It is also possible to get two extraneous solutions, or we could have 1 and 1 like in this case, but you just have to check. All right, so that's the theme of our section, which was radical and rational equations. And the reason I've grouped them together is because they both may contain extraneous solutions. Let's take some time to practice. Now I'd like you to head on over to Khan Academy and hit up the section called Radical and Rational Equations. And we're going to spend a bit of time on this because I'd like you to see if you can get all the way up to level 4 and really try to master this. So good luck and have fun.